The development and ongoing deployment of the GJ-11 Sharp Sword unmanned combat air vehicle constitutes a pivotal evolution in modern military aviation, marking a definitive transition from conceptual research and isolated technology demonstrations to the tangible integration of a low-observable, autonomous strike and reconnaissance platform into active tactical planning and force structure. This progression is most authoritatively demonstrated by the platform's confirmed presence at a forward operating location, specifically the Shagatz Air Base in the Tibet Autonomous Region, during the latter part of the 2025 calendar year. This deployment is critically significant not for its novelty but for its context. Shagatz is not a secluded test range but a bustling, dual-use military-civilian airport situated at an extreme altitude and serves as a key hub for ongoing surveillance and deterrence operations along a sensitive geopolitical frontier. The basing of multiple GJ-11 airframes at this location for a sustained period, co-located with other active military assets including flanker variant fighter aircraft and WZ-7 Soaring Dragon reconnaissance drones, provides incontrovertible evidence that the program has entered a phase of advanced operational utility evaluation. This phase focuses on validating the system's performance not in a controlled laboratory setting but within the complex, real-world variables of a high-altitude environment, which imposes unique stresses on engine performance, lift generation, and sensor acuity, and, more importantly, within the existing command, control, communications, and intelligence infrastructure of a theater command. This process is essential for refining the tactics, techniques, and procedures that will govern the platform's use in a potential conflict scenario, moving beyond the question of can it fly to the more critical question of how will it be used effectively alongside other assets. The engineering philosophy underpinning the GJ-11 is fundamentally predicated on the imperative of survivability and efficacy in an anti-access, area denial, A2AD battlespace, which is characterized by dense, overlapping, and sophisticated air defense networks. The airframe's tailless flying wing configuration is the architectural cornerstone of its low observable characteristics, a design choice that eliminates the large, perpendicular radar reflectors of vertical stabilizers and allows for the alignment of all wing and body edges to channel reflected radar energy into a very limited number of narrow beams, rather than scattering it widely. This primary stealth advantage is augmented by a deeply integrated propulsion system. The engine air intake is strategically positioned on the upper fuselage to shield the compressor face, a significant radar source, from ground-based emitters, while the exhaust system is meticulously engineered to rapidly cool and diffuse hot gases, thereby drastically reducing the platform's infrared signature. The airframe's construction undoubtedly employs a high percentage of advanced composite materials, which are inherently less reflective to radar than metals, and is coated with specialized radar-absorbent materials and paints that convert incident radar energy into heat. To maintain this carefully managed stealth profile during mission execution, the GJ-11 is equipped with a fully internal payload bay. This design feature is non-negotiable for a penetrating strike platform, as external stores would catastrophically increase its radar cross-section. This bay is configured to carry a variety of next-generation, precision-guided munitions, likely including small-diameter bombs and air-to-ground missiles, and can be reconfigured to house specialized mission payloads for electronic warfare or long-range sensing. The operational mandate for the GJ-11 is specifically tailored to the most demanding missions at the outset of a high-intensity conflict, where achieving air superiority is contested and uncertain. Its primary and defining role is that of a first-wave penetrating strike asset. In this capacity, GJ-11 formations would be tasked with autonomously navigating through heavily defended airspace to identify and neutralize an adversary's most critical, fixed, high-value targets. This target set is designed to paralyze an enemy's defensive and command capabilities and includes long-range early warning radar installations, key nodes of integrated air defense systems such as surface-to-air missile batteries and their associated command vehicles, fixed command and control centers, critical airfield infrastructure including runways and hardened aircraft shelters, and strategic logistical hubs. By systematically dismantling these assets, the GJ-11 creates temporary and localized air superiority, effectively punching a hole in the adversary's defensive umbrella for subsequent, potentially less stealthy, manned aircraft like bombers or multi-role fighters to exploit. A co-equal primary mission is the execution of persistent, survivable intelligence, surveillance, and reconnaissance operations within denied areas. The platform's low observability and projected long endurance enable it to linger for many hours in proximity to areas of interest, providing a continuous, all-weather, day and night stream of multi-spectral intelligence, including high-resolution electro-optical infrared imagery, synthetic aperture radar mapping, and signals intelligence that is immune to the predictable overflight schedules of satellites and avoids the political and personnel risks associated with manned missions deep behind enemy lines. The true strategic value of the GJ-11, however, is fully realized only when it is understood as a synergistic component within a larger, networked combat system, rather than as a standalone platform. The most transformative operational concept for its employment is advanced manned-unmanned teaming. In this paradigm, a flight of GJ-11s would operate under the tactical control of a manned aircraft, such as a J-20 stealth fighter, potentially in its two-seat configuration, which is ideally suited for the complex task of managing multiple unmanned assets. In this loyal wingman or networked collaborative combat construct, the GJ-11s function as an extension of the manned platform's capabilities. They can be commanded to fly ahead as an advanced sensor picket line, using their own onboard systems to radiate, or, more likely, use passive sensing, to detect threats and build a comprehensive situational awareness picture that is then shared with the manned aircraft, keeping it safely out of the most dangerous airspace. Alternatively, the GJ-11s can be designated as the primary shooters, engaging targets that are identified and designated by the J-20, thereby allowing the manned fighter to remain silent and stealthy while acting as a battle manager. Furthermore, the modular nature of the internal payload bay allows for the fielding of dedicated electronic warfare variants, which could accompany a strike package to actively jam enemy radars or disrupt communications, creating a protective electronic bubble for the formation. This level of integration represents a fundamental shift from platform-centric warfare to a truly system-of-systems approach, dramatically complicating an adversary's targeting and defense planning. The pathway to this operational state has been characterized by a deliberate and sequential development strategy. The program's origins can be traced back over a decade to a subscale technology demonstrator, which conducted its inaugural flight in 2013, with the primary goal of validating the fundamental flight controls and stability of the flying wing design. A major generational leap was publicly revealed in 2019, with the appearance of a mock-up showcasing a radically refined and production-ready configuration, with significantly improved surface finish, fully integrated control surfaces, and a more sophisticated overall shaping, indicating that lessons from years of clandestine testing had been successfully incorporated. The period following this reveal was marked by an intensified tempo of flight testing at major experimental facilities, such as the sprawling base near Malin, where satellite imagery frequently captured multiple GJ-11 airframes conducting simultaneous operations, signaling a focus on mission systems integration, weapons testing, and evaluating collaborative behaviors between multiple drones. The deployment to Shagatz in 2025 is the most conclusive milestone in this sequence, representing the platform's graduation into the operational evaluation phase of a frontline command. In parallel, extensive evidence, including the presence of full-scale mock-ups at naval research and training facilities, confirms the active development of a carrier-capable derivative. This naval variant necessitates a suite of specific modifications, including strengthened landing gear and airframe to withstand the violent forces of a catapult launch and arrested landing, an integrated arrestor hook, and corrosion-resistant treatments to withstand the harsh maritime environment, underscoring the strategic intent to embed this capability across all domains of warfare. The GJ-11 Sharp Sword is far more than an incremental improvement in unmanned aviation. It is the concrete manifestation of a doctrinal shift that redefines the roles and relationships of assets in the aerial battlespace. Its journey from a proof-of-concept demonstrator to a platform undergoing tactical evaluation at a contested border underscores a profound and sustained commitment to mastering the complexities of autonomous, networked, and stealth-based warfare. The platform's ultimate impact will be determined not merely by its individual performance specifications, but by the success with which it is woven into the fabric of joint operations, enhancing the capabilities of manned aircraft, providing unprecedented situational awareness, and presenting adversaries with a multifaceted and resilient threat that is exponentially more difficult to counter than any single platform. Its continued deployment and the evolving patterns of its use provide the most reliable indicator of a future where unmanned systems are central, rather than supplementary, to the projection of air power and the deterrence of conflict.